So now we're just gonna create the dimensions and basic game panel. So first, we're gonna need it to extend JPanel, which is the user interactive part of our JFrame. We are going to make two dimensions, screen width, and we're going to set that equal to 550. Also, that is an integer. We're going to also create another integer called screen height, and we're going to set it to 550. And this 550 is referring to 550 pixels. In our constructor, we're then going to create the basic functionality of this game panel. So we're going to first create its dimensions. So we're going to set preferred size to a new dimension. It's going to be screen width, and screen height as the width and height of this game panel. We're going to set the background to a color that is going to be black in uppercase. We're going to set focusable to true. And we're going to then add an instance of game panel in our game frame class so that it will run. So we're going to add a new game panel. And we're going to build it. So when we run this, it should show us a new game panel. Now what we're going to do is go back and create all the variables we need. In addition to screen width and screen height, we also need quite a few variables. We need an integer called unit size, and we're going to set this to 25. We're also going to need a delay integer that is basically the time in milliseconds between every frame of our graphics. We need a boolean called running to tell the code whether we are in or out of the game. And right now we're out of the game, so we're going to set our boolean running to false. We are going to create a variable called timer for a new timer, a new board variable, an initial position cell for a snake, and a snake variable. We also need an integer, and we're going to call this start. This integer start is the number of body parts the snake starts out with. We're also going to have a private character called direction, and we're going to set this to right because we want the snake to initially go right. We're going to have a boolean called generate food, and this boolean we're going to set to true because we want to generate food first. And we also have an integer called extra, and then we're going to set this to 50. Extra is the space between lines between the text we print on our window. So now that we've created all these new variables, we also need to create new instances for these variables. So we're going to create a new board, and we're going to set it to first the row count, and that's screen height divided by unit size. And the column count will be screen width divided by the unit size. And that is the maximum amount of cells for column and row that the board can fit, with the cell being a unit size pixel amount. For the init position, or the initial position, we have a new cell. and we're going to set it to screen width divided by unit size, or screen height, divided by unit size times 2, since we want it to be right in the middle of our game board vertically. However, for horizontally, we need to do the same thing, but index it to start -1 left. This is because we want to add start -1 body parts in front of the initial position for our snake. And we will just make our new snake with the variables initial position and board. Afterwards, we also want to call start game, which is a function that we will create in a minute. So now we will make that start game function and be a public void. And for this, we want to set running to true because we have now started our game. We're also going to create a new timer. And we're going to make sure that it runs every time for increment delay, so 75 milliseconds. And we want it to run a function called this. And for that, we're going to use action listener. So we're going to call that element and use it in our class. And so we're going to call action listener, and basically this method is going to be used as this and going to be run every time delay happens. And right now we're going to start timer since the game has started. Next, what we're going to do is create a paint component. And it's going to take in graphics G. So we're going to call the paint component built in and add in the graphics G. But we're also going to have another draw function in which we'll draw the actual board. Obviously, we haven't yet created that instance draw, so we're going to do it right now. We're going to make a public void function that is nominally draw, and we're going to make it take graphics G. So if our boolean running is true, then we know that we're in the game. So we want to draw our board. We're going to make a function for this later. And if not, we're just going to call our game over screen, which we'll also create later. The drawBoard function also uses graphic G. And this drawBoard function is going to need the cells array from the board class. And we're just going to call this array that we get cells to because it's easier. And we're going to use the get cells to actually get the array. Now that we've gotten the array, we can increment through the elements in the array. So we're going to do the same thing where we start with the row counter as 0 and then increment the row until it is less than the maximum row count it can be. And right now that is screen height divided by unit size. And to get all the positions, we're also going to have an embedded column counter, and column has to be less than the screen width divided by unit size. So now that we have the for loop that increments through all the positions, we want to check each position. So first, we want to start out with checking if it's a wall. So we're going to get that type. If that type indeed is wall, we're going to set the color of our graphics to blue because we're going to make all the wall cells blue. Then we're going to create a rectangle based on the C and R position. Note that C is X and rho is Y in this case. So we're just going to fill a rectangle with G. But we also have to consider that the size of the cells is not 1, it is unit size. So we have to multiply C times unit size to account for the increased size of our cells. And then again, we just pass in unit size as height and width. Now we have to check for 2 more cases. The first case is if the cell's type is food. If so, we need to create a red circle in that cell. So what we're going to do is set the color to red, and then instead of filling a rectangle, we're going to fill an oval. Second, and lastly, we also need to check if the type is a snake. And if so, we're just going to create a green square instead of a blue square. Remember to use else if for the food and snake because we're checking in other cases. So now we want to create the lines that will go through our board. So we'll first set color to white. Then what we want to do is create 2 for loops. And each will have I be less than screen height divided by unit size, and also screen width divided by unit size. We're doing this because we want I to go from 0 to the screen height dimension, but also we're later going to multiply I by unit size so that it increments by unit size each time, so the cell size. First, we're going to start with the horizontal lines. Our constant will be the vertical position, and this vertical position will be I times unit size. So we're incrementing I by unit size. But we also want our width to change so that we can draw in a line. Our first x1 position will be 0, and then we'll go to the dimension of the screen width. We will do the same thing with the vertical line, except this time the x position will be the constant. After we create the draw board function, we also need to create the game over screen. And we're going to add graphics G for this again. So first, we want to set our font color to red. And for that, we're just going to use g.setColor. Next, we're going to set the font of G. And we're going to have our new font be Courier. New. The font will be bold. And have the size of 22. Next, we're going to use something called font metrics for a data type. And we're going to call this metrics. We're going to set it to, or get, the font metrics of our specific font right now. We're going to use get font metrics and get font for that. We will also have the height of this string, which we'll call g height. And we're gonna basically just get the height of this string using metrics.getHeight. Next, we're gonna draw the string. So we want our string to be game over, so we're gonna put that in as a string. Our x position will be the screen width negative the width of game over because we want it to be centered, and then we'll divide that by 2. And we'll just have the screen height be in the middle, so screen height divided by 2. Now we're going to make a string called points that will store the points of our snake at the end, which is basically just the length of the snake. So what we're going to do is get the linked list that our snake was contained in, and we want to know the size. After we know the size, we can then convert this integer into a string. Afterwards, we're going to add the string score with a colon to give more readability to users. Now that we've created our points variable with the correct string, we can now again set our font. So we don't want it to be the exact same font size as the font before, so we're going to create a new font for G. And we're going to call this font Courier New, and we're going to set it to bold. But this time we're going to set the size to 12. We're also going to get font metrics. Again, because we haven't gotten a new font or set a new font. So we're going to draw the string again using screen with the shifted number so that we make sure that the points string is in the middle. Don't forget to put points as string. And this time we also need to shift the screen height. We want the points to be below, so we're going to add numbers. So we're first going to add g height, which is the height of the game over string. And since we don't want our string to be just below, for readability, we're going to also add a space called extra, which we defined earlier. We're going to divide this number by 2. So now we have created all the graphics parts of our snake game panel class. So now what we're going to do is have a boolean to check if the snake crashes. And we're going to set it to the next cell that we want the snake to go to. And this is going to be a boolean. So if the board element at this particular position next cell, so we're going to use next cell dot get row, next cell dot get call. If that particular position equals the type snake, then we know that we've crashed because a snake cannot go through itself. In the same way, a snake cannot go through a wall, so we're also going to check for that too. So if those conditions are true, then we're going to return true because we have crashed. If not, we also want to check for one more thing. We want to check if the snake has on the cell with the apple. If so, then we have to generate food. So we're going to set generate food to true again. after all this, if we haven't returned true already, then we know that we haven't crashed. So we're gonna return false. Also, make sure instead of equals equals, we're gonna do or. Now that we've created this check crash boolean, we can now create our action listener, which is used in our timer to just keep over and over again repeating that function every delay, so 75 milliseconds. And we're going to call this public void action performed. The name is important, so keep the name here because it is built in. And we're going to take an action event E. We have to use the add override command above because we want to add some more code to this pre-built-in function. So if the game is running, we want to move our snake. So we need to get the first part of our snake because that's what we want to move. And we're going to use the getHead function for that in snake, and we're going to use the variable head. Now we need to create a switch statement called direction, testing all the directions our snake can be. And based on that, we want to change the position of head so that it is a new position or the next position that the snake will be in. The first case is that the snake is going left. If so, then the head equals a new cell that is one left of the original position. So that is column position -1. We also want to break in case there's any confusion, and while we're running this, the direction does change based on what keys we pressed. Next, we want to have a case for the right, and instead of incrementing the call, we want to add one to the call position. Next, for up, instead of changing the column position, we're going to decrement the row because we want to go up, and 0, 0 for our board is the top left. And for our case down, we want to, instead of changing the column or decrementing the row, we want to add to the row position. After we've gotten the next cell or changed the head, we now need to check if we crashed. If so, then we're just going to set running to false because our game has ended. If not, and generate food is true, then we know that we need to generate some food. So we're going to call that board function that does that. And now we're going to set generate food to false because we no longer need to generate food. We now need to just grow the snake because it has eaten an apple, so it grows when it does that. And if the snake hasn't crashed and hasn't grown or eaten an apple, then it just moves. And after all that, we're going to repaint. Repaint calls our paint component function that we did above. So it is this one. Now all we have to do is create a class called myKeyAdapter. And we're going to extend this from keyAdapter in java.awt.event. We're going to use @override again because we're using a function that was built in. And this function is called public void keyPressed. It takes in the input key event E. So we're going to have a switch statement to test when we get the key code from this key event E. So we have to test 4 keys. We want to test the left key, which is key event.vk left, or vk_left. And if the direction is right, we can't actually set our direction to left because the snake cannot go in 180 degrees because it would just hit itself. So if it's not right, then we can set the direction to left. We also need to break after this. We also have 3 more keys we need to look at. VK right, VK up, and VK down. For right, instead of the direction of being able to be right, we can't have it to be left because that's 180 degrees. And if so, or if not, we can set the direction to right. In the same way, if we want to set it to up and it's not 180 degrees or down that direction currently, then we can set it to up. And finally, if we want to set it to down and it's not currently up, we can set it to down. And before we can actually run it, we also need to create an instance of key adapter. And so in our game panel constructor, we're going to add key listener using our function myKeyAdapter. And so when we run this code, what will happen is that we'll get our snake game. So we're all done. So if you have any bugs or errors, just go back into this video and try to see what you did wrong. It's common that you might have mistyped something or just forgotten a line of code, and that's okay, everyone makes mistakes. If you want an extra challenge after this video, you can always personalize your snake game. A few suggestions I have are letting the user choose the color scheme of your snake game, making the snake look like it has bounced off itself or the wall after it has crashed. So basically, how would you would do that is that you would increment the snake position a little downwards and use that frame and then show game over. So it's backed up a little bit or bounced. And finally, what you could also do is keep track of multiple apples. So you have 3 apples in the game. And if you want any other personalization ideas, you can always go to the Google Snake Game because they have a lot of different games and ideas. So thank you for watching this video, and I hope you will watch all the other tutorials on the Codology website.